Welcome student to a new session of engineering mechanics. In today's session, I am going to discuss the whole 2022 winter semester questions with you. So this video may be a bit longer than you expected. So watch the full video and solve with me. So student, before starting the session, let's first understand the क्वेश्चन पैटर्न. सो पहले क्वेश्चन पैटर्न को समझ लेते हैं. क्या है क्वेश्चन पैटर्न? ओके, देखो यहाँ पर क्लियरली इंस्ट्रक्शन है कि आंसर एनी 5 क्वेश्चन इंक्लूडिंग क्वेश्चन नंबर 1 एंड क्वेश्चन नंबर 2. दैट मीन्स क्वेश्चन नंबर 1 एंड क्वेश्चन नंबर 2 इज कंपलसरी. 1 और 2 नंबर क्वेश्चन कंपलसरी है एंड बाकी जितना क्वेश्चन है उसमें से 3 क्वेश्चन हमको अटेंड करना है. 3, 4, 5, 6, 7. From 3 to 6, 3 to 7, we have to attend only 3 number of question. Okay, so total mark is 80 mark. This first section is of 20 mark. All question are compulsory. Question number 1 and question number 2, you have to answer only 6 number of question. Okay, each question is having 5 mark. Total is 30 mark. Okay, then from question number 3, 4, 5, 6, 7, ये 3 से 7 नंबर तक क्वेश्चन जो है सभी क्वेश्चन का मूल्यांकन जो है वो 10 मार्क है. इस क्वेश्चन का मूल्यांकन 10 मार्क है. सो फ्रॉम दिस 5 क्वेश्चन यू हैव टू अटेंड 3 नंबर ऑफ ओनली. ओके, so that's your choice. You have to attend 3 number of question. Let's start the answering of question paper. First we will solve question number 1 bit by bit. Question number 1, bit A. The question is asking define elasticity. So we will define elasticity. So the word elasticity, we have to define this word. So first point is elasticity is a property. Remember, it is a property of material or body by virtue of which upon application of force the body get deformed. Upon application of force body get deformed and after removal of force body regain its original shape. Okay, so this is like the behavior of a rubber band. So behavior of a rubber band can be explained by the property elasticity. Example, behavior of a rubber band. Okay, when we stress the rubber band, suppose this was a rubber band, when we stress the rubber band the length get increase, length get increase. After stopping stretch in few seconds, in few microsecond or nanosecond, the band regain its original shape or size. Okay, so basically इलेक्ट्रिसिटी में क्या होता है, जब भी हम फोर्स अप्लाई करेंगे बॉडी पे, इफ द बॉडी इज इलास्टिक बॉडी, देन बॉडी डिफॉर्म करेगा फास्ट, उसका साइज चेंज होगा, उसका शेप चेंज होगा ड्यूरिंग all the time when the force is applied into the body. ओके, जब तक फोर्स अप्लाइड होके रहेगा, बॉडी का साइज चेंजेस होके ही रहेगा. ठीक है. द सेकेंड वी रिमूव द फोर्स, बॉडी जो है वो अपना सेफ रिगेन कर लेगा. ओके, दिस इज इलेक्ट्रिसिटी. देन क्वेश्चन नंबर बी इज आस्किंग टू define force, write down its SI unit. Define force. So force को हम define करेंगे. Basically force is an agent which tends to destroy or destroy the state of rest or uniform motion of a body, and also it can change or tends to change the size of any body. ओके, तो फोर्स क्या है? फोर्स एक एजेंट है, एक इन्फ्लुएंस है, जिसके वजह से हम बॉडी अगर रेस्ट कंडीशन में है, रेस्ट बॉडी को फोर्स अप्लाई करके हम मोशन में ला सकते हैं. सो यहाँ पे एक बॉडी रेस्ट में है, अगर रेस्ट बॉडी को हम फोर्स अप्लाई करेंगे फ्रॉम दिस साइड, रेस्ट बॉडी को अगर हम फोर्स अप्लाई करेंगे फ्रॉम दिस साइड, देन बॉडी जो है, बॉडी विल मूव टुवर्ड्स डायरेक्शन ऑफ एप्लीकेशन ऑफ फोर्स. ओके, so this happen because of application of force only. Suppose another body move कर रहा है, another body is moving. Okay, body is moving and we are applying force in the opposite direction. फोर्स जो है ऑपोजिट डायरेक्शन में अप्लाई कर रहे हैं. सो यहाँ पे क्या हो सकता है, बॉडी को जो है फोर्स बॉडी को रेस्ट में भी ला सकता है, बॉडी का जो सेंस ऑफ मोशन जो है, इस डायरेक्शन में बॉडी जा रहा है, सेंस ऑफ मोशन जो है वो ऑपोजिट भी कर सकता है, ऑपोजिट डायरेक्शन में भी बॉडी को मूव कर सकता है. लेट्स कंसीडर अनदर बॉडी है एंड वी आर अप्लाइंग फोर्स फ्रॉम टॉप टू डाउन डायरेक्शन. जब यहाँ पे फोर्स अप्लाई होगा तब देयर इज ए चांस दैट बॉडी में गेट डिफॉर्म, बॉडी का साइज चेंज हो सकता है. ठीक है, बॉडी में गेट डिफॉर्म. सो बाय द एप्लीकेशन ऑफ फोर्स वी कैन change the state of rest or motion of the body. We can also deform a body, right? That is how we can define force. Then we will know the SI unit of force. So force equal to mass into acceleration. So mass का SI unit क्या है? kg. acceleration का SI unit क्या है? मीटर पर सेकेंड स्क्वायर. सो यहाँ पे क्या लिखा है, क्वेश्चन में लिखा हुआ है SI यूनिट्स, प्लूरल फॉर्म में लिखा हुआ है SI यूनिट्स. सो वी हैव टू डिफाइन द SI यूनिट्स, ऑल पॉसिबल SI यूनिट्स. ओके, फर्स्ट जो है kg मीटर पर सेकेंड स्क्वायर होगा एक, अनदर इज kg force, and finally Newton. These all are the SI units. Next question. Question 1, bit C. Define coplanar and collinear forces. So bit C जो है ये system of force से आया है. Here we have to define coplanar and collinear forces. कोलिनियर फोर्सेस, ये दोनों फोर्स को हम डिफाइन करेंगे. सो फर्स्ट जो है वी विल डिफाइन कोप्लानर फोर्सेस. सो कोप्लानर फोर्सेस क्या है? सारे फोर्स जो है सब फोर्स का लाइन ऑफ एक्शन will lie in same plane if the line of action of all forces lies in a same plane, then the system of force can be called as coplanar forces. Okay, so if this is a force, F, then this line, this total line is the line of action of force. So coplanar force को अगर हम diagrammatically define करेंगे, let's take number of force F1, F2, F3, F4, F5. This is x-axis and this is y-axis, and total is xy plane. Let okay. See, let's this is F1, F2, F3, F4, F5. देखो यहाँ पे F1, F2, F3, F4, F5 फोर्सेस जो है सभी फोर्स का लाइन ऑफ एक्शन lying in xy plane. So this system of force is a coplanar force. Then collinear force. Collinear forces mean if the line of action of all forces lies in a single line, then the system of force is called collinear force. So let's see and diagrammatically how we can define collinear force. So this is let F1, okay, and let this one be F2. Let this one be F3, and यहाँ पे और एक फोर्स है that is F4, and यहाँ पे देखो all F1, F2, F3 and F4 have common line of action. So these forces are nothing but a collinear forces system. collinear force system. Next question is define couple. Question number E. couple couple को अगर हम डिफाइन करेंगे, it can be defined by two equal and opposite force separated by a perpendicular distance consist a couple. Okay, two equal opposite force separated by a perpendicular distance consist a couple. So यहाँ पे हम इसको और एक वे में डिफाइन कर सकते हैं, टू इक्वल an opposite force separated by perpendicular distance consists a couple. Let me explain by the help of a diagram. Okay, so let be this f1, let be this f2, and जो distance जो है separation distance जो है, let be this L. Okay, according to our definition, the magnitude of f1 is equal to the magnitude of f2. Let this be f. Okay, and ये जो इसका सेपरेशन डिस्टेंस जो परपेंडिकुलर सेपरेटेड डिस्टेंस जो है उसको हम बोलते हैं कपल आर्म. ओके, सो यहाँ पे टू फोर्सेस है, F1 and F2. So F1 F2 having equal magnitude and they are separated by perpendicular distance. That means they are consisting a couple. So couple जब हम डिफाइन करेंगे, अगर मैथमेटिकली कपल को हम कैसे दिखाते हैं, बाय द हेल्प ऑफ मोमेंट्स ऑफ कपल, बाय द हेल्प ऑफ मोमेंट ऑफ कपल. Moment of couple is equal to magnitude of force into couple arm. So moment of couple is the product of magnitude of force into couple arm. That means the length of the perpendicular distance. So that is F into L. This is the moment of couple. और यहाँ पे हमको if we show the sign convention, then clockwise couple may be taken as negative and anti-clockwise couple may be taken as positive. This is clockwise. Clockwise means this in this sense, anti-clockwise means in opposite to the sense of movement of hands of clock. It is anti-clockwise. Anti-clockwise. Then units Newton meter, Newton millimeter. These are the units of couple. Okay. Then next question. State perpendicular axis theorem. Bit F perpendicular axis theorem. So परपेंडिकुलर एक्सिस थ्योरम ये जो है मोमेंट ऑफ इनर्शिया चैप्टर से आया है. सपोज यहाँ पे बॉडी है. सपोज दिस वन इज द बॉडी एंड बॉडी से कुछ दूरी एंड बॉडी से कुछ दूरी पे एक एक्सिस है. ओके, एंड दिस वन बी लेट a axis, and we are intending to find out the moment of inertia of the body about the axis. Moment of inertia of this body about this axis. So इसी केस पे we can take the help of perpendicular axis theorem. So perpendicular axis theorem states that the moment of inertia of a body about any axis parallel to its centroidal axis, remember, about any axis parallel to its centroidal axis is equal to the sum of the moment of inertia of that body about its centroidal axis and the product of the area and the square of perpendicular distance between the centroidal axis of the body and the axis of consideration. Okay, so let's ये जो है एक centroidal axis है and let's ig be the moment of inertia of the body. ig जो है moment of inertia of body about its centroidal axis. a जो है let's a be the area of body. h जो है perpendicular distance between central axis and axis a. ये perpendicular distance है. Let this be the h. So according to perpendicular axis theorem, IAA, moment of inertia about any axis parallel to the central axis of the body is equal to the sum of moment of inertia of the body about its central axis plus the product of area of the body and perpendicular distance between the square of perpendicular distance between the central axis and the axis about which we are calculating the moment of inertia. So this is nothing but perpendicular axis theorem. IAA equal to IG plus AH square. Always remember this particular theorem we use to calculate the moment of inertia about any axis parallel to the central axis or the moment of inertia about any axis external to the body or anywhere in the body also. Self-locking machine is those type of machine where after removal of effort the machine is not capable of doing any work in reversible direction. So if we remove the effort, then मशीन जो है वो रिवर्सिबल डायरेक्शन में वर्क नहीं करेगा, एंड दैट टाइप ऑफ मशीन को हम बोलते हैं सेल्फ लॉकिंग मशीन. एंड सेल्फ लॉकिंग मशीन एग्जांपल इज स्क्रू जैक. ओके, स्क्रू जैक जब हम यूज करते हैं, हम लोग फर्स्ट क्या करते हैं, स्क्रू जैक को गाड़ी के नीचे लेते हैं. उसके बाद वी आर अप्लाइंग इफोर्ट. ओके, इफोर्ट डालते हैं मतलब उसका जो हैंडल होता है उसको रोटेट करते हैं, मतलब हम इफोर्ट दे रहे हैं. इफोर्ट देने की वजह से क्या होता है, स्क्रू जैक का जो वर्टिकल एक्सिस है वो टॉप डायरेक्शन में मूव करता है. आफ्टर वी स्टॉपिंग प्रोवाइडिंग एफर्ट, क्या वर्टिकल एक्सिस टॉप डायरेक्शन में मूव करता है? क्या वर्टिकल एक्सिस नीचे गिर जाता है? नहीं. इट मीन्स उसका मूवमेंट जो है, वर्टिकल एक्सिस का जो मूवमेंट जो है वो लॉक हो जाता है. एंड दिस टाइप ऑफ मशीन को हम बोलते हैं सेल्फ लॉकिंग मशीन. एंड ऑलवेज रिमेंबर, सेल्फ लॉकिंग मशीन का जो एफिशिएंसी है, ओके, इज ऑलवेज लेस देन 50%. एंड सेल्फ लॉकिंग किसी मशीन का अगर हम एफिशिएंसी निकाल रहे हैं, उसका मतलब उसका आउटपुट के साथ इनपुट कंपेयर कर रहे हैं. सो फॉर लिफ्टिंग मशीन efficiency is mechanical advantage by velocity ratio. Remember this formula. ये भी 2 मार्क आ सकता है. ओके, नेक्स्ट क्वेश्चन नंबर 8. डिफाइन सेंट्रोइड. डिफाइन सेंट्रोइड. Centroid, always remember, centroid is the CG of two-dimensional figure, and for plane figure, centroid is the geometric center. ओके, प्लेन फिगर मतलब टू डायमेंशनल फिगर के लिए सेंट्रोइड जो है इट्स द ज्योमेट्रिक सेंटर. सो एग्जांपल देंगे. एग्जांपल फॉर रेक्टेंगल ऑफ साइड B and D, centroid lies at coordinate B by 2, D by 2. Okay, suppose this is x axis, this is y axis, and यहाँ पे एक रेक्टेंगल है. ओके, दिस इज y एक्सिस. स्ट्रेट करते हैं y एक्सिस को. सो दिस इज b एंड दिस इज d. तो सेंटर जो है पूरा बीच में रहेगा, b by 2 एंड d by 2. ओके, नेक्स्ट बिट. डिफाइन कोएफिशिएंट ऑफ restitution. Question number I. Define coefficient of restitution. Coefficient of restitution. So coefficient of restitution is nothing but the ratio between velocity of separation and velocity of approach between two body when they collide when they collides. So देखो, let's, this is body 1, this is body 2, they are moving with velocity u1 and u2. After some time they are colliding, and after colliding they are again getting separated, and velocity of body 2 be velocity 2 and velocity of body 1 be velocity v1. Okay, this is before collide, means they are approaching. Here they are colliding, body 1 body 2 body 1 body 2. Here they are separating. For body will get collides if u1 is greater than u2, and after colliding they will get separated if v2 is greater than v1. That means their velocity of separation is nothing but u1 minus u2. Sorry, velocity of approach is nothing but u1 minus u2, and velocity of separation is nothing but v2 minus v1. Okay, so according to Newton law of collision, E equal to v2 minus v1 by u1 minus u2. This is the coefficient of restitution, and E is nothing but the coefficient of restitution, and coefficient of restitution is unitless. Remember, coefficient of restitution is unitless. And another important point, the value of coefficient of restitution is lie between 0 to 1. If you get the value of coefficient of restitution as 0, that means the bodies are inelastic. Okay, and if you are getting the value of E h1, then the body are purely elastic. So this is all about coefficient of restitution. Next question, bit J, what is D'Alembert principle? What is D'Alembert principle? It states that if a rigid body acted upon by number of forces, then this system can be reduced to a single resultant force, whose magnitude and direction as well as line of action may be found out by the method of graphical statistics. So again I am repeating the statement. If a rigid body is acted upon by a system of forces, this system may be reduced to a single resultant force whose magnitude and direction as well as line of action may be found out by method of graphical statics. Suppose this is a body, this is a body, and this body is moving in this direction with a acceleration of a, and let mass of the body is m, and let different forces F1, F2, F3, these are acting on the body. So according to D'Alembert principle, we can represent F1, F2, F3 by the help of single resultant force. Let P be the resultant force, which is nothing but F1 plus F2 minus F3, because all the forces are collinear. So by the help of D'Alembert principle, we can write this equation as P equal to ma, or P minus ma equal to 0. So this is nothing but the equation of motion of the body. So why ma? Because the body is moving with the acceleration of a, it means it will produce some forces. Ma is the force. Okay, so the resultant force will get equal with the mass into acceleration. So this is nothing but the D'Alembert principle. Next we will solve question number 2. So let's see what are the question. Question number 1, state and prove Lami's theorem. Statement. So it states that if three coplanar and concurrent forces are in equilibrium, then each force is directly proportional to the sine of angle between other two forces. That three coplanar and concurrent forces are in equilibrium, then each force is directly proportional to sine of angle between other two forces. Let's draw the diagram. So let's this one be P, this one be Q, and this one be R. Let alpha be the angle between Q and R, beta be the angle between P and R, and gamma be the angle between P and Q. So as per Lami's theorem, each force is directly proportional to sine of angle between other two forces. That means P is directly proportional to sine alpha, Q is directly proportional to sine beta, and R is directly proportional to sine gamma. So if we rewrite this equation may be written as P by sin alpha equal to Q by sin beta equal to R by sin gamma, and this is nothing but the Lami's theorem, which is applicable for three coplanar concurrent forces are in equilibrium. So let's draw the diagram again. I have already drawn P, Q and R. Angle between P and Q is gamma, angle between Q and R is alpha, angle between P and R is beta. Okay, let's draw P, the force Q over here again. So if this is Q, ये जो Q force है इसको हम parallelly यहाँ पे भी दिखा सकते हैं. So this force can be represented over here, and R जो है ये R force को हम यहाँ पे दिखा सकते हैं. So this is R and this is Q. Let's rename this triangle A, B and C. In triangle ABC, angle ABC is equal to 180 degree minus beta. This angle is beta and we are calculating this angle ABC. So this angle and this angle summation is 180 degree. So this angle will be 180 degree minus beta. Again, this line AC, and suppose this line B and D. AC and BD are parallel, and these two lines are intersected by line BC. Line BC जो है AC and BD को intersect कर रहा है. That means angle ACB and angle BCD are alternate angle. That means angle ACB will be equal to angle CB and D, angle CBD, because they are alternate angle. That means angle ACB equal to angle CBD equal to 180 degree minus alpha. So यहाँ पे ये 180 degree minus beta जैसे हुआ, ये भी 180 degree minus alpha वैसे ही होगा, because we are calculating this angle and we know this angle is alpha. So this angle plus this angle is 180 degree. That means angle CBD will be 180 degree minus alpha. Then in triangle the remaining angle is angle CAB. ये भी ये एंगल कैलकुलेट करना है. ओके, ये एंगल कैलकुलेट करना है मीन्स we know in triangle summation of all angle are (180 degree). That means angle ABC plus angle BCA plus angle CAB equal to 180 degree. Again we know angle ABC का वैल्यू कितना है 180 डिग्री माइनस बीटा, 180 डिग्री माइनस बीटा. एंगल BCA का वैल्यू कितना है BCA और ACB इज इक्वल टू एंगल 180 डिग्री माइनस अल्फा, एंगल 180 डिग्री माइनस अल्फा, एंड वी डोंट नो एंगल CAB वैल्यू. टोटल समेशन इज 180 डिग्री. So 180 plus 180 is equal to 360 degree minus alpha plus beta plus angle CAB is equal to 180 degree. And see, in this diagram, alpha plus beta plus gamma equal to 360 degree. That means alpha plus beta equal to 360 degree minus gamma. Okay, so put this value in this equation. So 360 degree minus 360 degree minus gamma plus angle CAB equal to 180 degree. So gamma plus angle CAB equal to 180 degree. Then angle CAB we will get 180 degree minus gamma. So अभी हमको angle CAB का वैल्यू मिल गया. So now we have got angle CAB value, and in triangle ABC now we have got all the three angles. So इसका वैल्यू कितना मिल गया? 180 डिग्री माइनस गामा. इसका वैल्यू मिल गया 180 डिग्री माइनस अल्फा. ओके, सो ये तीनों एंगल का वैल्यू हमको मिल गया. एंगल ए बी सी, एंगल सी ए बी एंड एंगल ए सी बी. So now we can apply sine law. By sine law क्या होता है? If this is a triangle and these A, B, C are the sides and these are the tip of the triangle, that means A by sine A equal to B by sine B equal to C by sine C. This is the sine law. So if we apply this sine law in this triangle, triangle A, B and C, then we will get AB by sine AB by sine ACB, AB by sine ACB AB by sine ACB equal to BC by sine BAC angle equal to AC by sine ABC angle. So AB side जो है that is nothing but P. See, AB side is nothing but force P. So force P is represented by AB side. So sine ACB is sine 180 degree minus alpha. So P by sine 180 degree minus alpha equal to BC. BC side, let's see. BC side is represented by sine the force R. So R by sine 180 degree minus gamma equal to Q by sine 180 degree minus beta. And we know sine 180 degree minus theta is equal to sine theta. So we will get P by sine alpha equal to Q by sine beta equal to R by sine gamma. Proved. Let's move to next question. Question number B. is asking us to calculate the angle between two equal force when the resultant of them are P and second bit is P by 2. So let's solve. Question B, two equal force of magnitude P. This is given. So we have to calculate angle between them. First bit, when resultant is P. When their resultant is P. When their resultant is P. So see, we know the parallelogram law of vector addition. So let's put the formula. By that formula we know resultant is nothing but root over of f1 square plus f2 square plus 2 f1 f2 cos theta, where theta is the angle between two forces. Theta is the angle between two forces. Okay, so r square equal to two forces are having equal magnitude, so f1 equal to p and f2 is also equal to p. So p square plus p square plus 2p square cos theta, and r is also p. P square equal to, if we take 2p square common, then 1 plus cos theta we will get. Okay, so यहाँ से p square and p square कट जाएगा. 1 equal to 2 1 plus cos theta. So 1 by 2 equal to 1 plus cos theta, or cos theta equal to 1 by 2 minus 1, which is equal to minus 1 by 2. So we will get theta equal to cos 120 degree equal to minus 1 by 2. So theta equal to 120 degree. Then second bit, resultant is p by 2. Let's put the same formula. R equal to f1 square plus f2 square plus 2 f1 f2 cos theta root over. That means r square equal to f1 square plus f2 square plus 2 f1 f2 cos theta, r square equal to p by 2 square equal to p square plus p square plus 2p square cos theta, p by 2 square equal to p square by 4 equal to, let's take 2p square common, we will get 1 plus cos theta. So p square get eliminated, then we will get 1 by 8 equal to 1 plus cos theta, or cos theta equal to 1 by 8 minus 1 minus 7 by 8, or theta equal to cos inverse minus 7 by 8. So by the help of calculator we can calculate this value, that is equal to 151.044 degree. This is our answer for bit 2. Let's solve next question. Derive velocity ratio for a compound gear train. Velocity ratio of a compound gear train. Let me take the diagram from the book. Okay, I am just taking the diagram from the book R.S. Khurmi. So this is nothing but a compound gear train. So this is gear 1 and this is gear 2 and gear 3. This is gear 2, this is gear 3. These two gear is mounted over a single shaft, and that is another two gear 4 and gear 5 is mounted over another one shaft. Okay, this is gear 4, this is gear 5, and this is gear 6. And for us, gear 1 is driver, and final we are getting output at gear 6. So final gear is gear 6. So it is also a follower. Okay, so apart from gear 6, gear 2, 3, 4, 5 are also follower. So we know the definition of velocity ratio for a gear train. It's a ratio of speed of follower to speed of driver. Speed of follower to speed of driver. Okay, this is nothing but velocity ratio for gear train. Let in this diagram, let n1, n2, n3, n4, n5 and n6 be the speeds of gear 1, 2, 3, 4, 5 and 6, and T1, T2, T3, T4, T6 are the number of teeth on gear 1, 2, 3, 4, 5 and 6 respectively. Okay, let's compare first gear 1 and gear 2. Okay, let's we compare first in gear 1 and gear 2. In between gear 1 and gear 2, the velocity ratio is speed of follower by speed of driver. So between gear 1 and gear 2 is our follower and gear 1 is our driver. So n2 by n1 is nothing but t1 by t2. t1 by t2. Okay, let's me erase. T1 82. This is equation 1. Similarly, see, gear 1 is driving, gear 2, and gear 2 and gear 3 are both are mounted on a single shaft. That means gear 2 and gear 3 are moving with same velocity, not the same velocity, same speed. Then gear 3 is driving gear 4 and gear 5 is driving gear 6. Okay, so next we will compare between gear 3 and gear 4. Like gear 1 and gear 2, gear 3 and gear 4 are there. In gear 1 and gear 2, gear 1 जो है gear 2 को ड्राइव कर रहा है, एंड gear 2 gear 3 दोनों एक सिंगल शाफ्ट पे लगे हुए हैं. दैट मीन्स दोनों का स्पीड सेम है. सो gear 3 is driving gear 4. So next we will compare gear 3 and gear 4, and next we will compare gear 5 and gear 6. So like gear 1 and gear 2, we will get the equation in between gear 3 and gear 4 and gear 5 and gear 6. Similarly, between gear 3 and gear 4, we will get n4 by n3 equal to t3 by t4. That is equation 2. And similarly, between gear 5 and gear 6, we will get n6 by n5 equal to t5 by t6. This is equation 3. Now we will multiply. Now multiplying equation 1, 2 and 3, we will get n2 by n1 into n4 by n3 into n6 by n5 equal to t1 by t2 into t3 by t4 into t5 by t6. Now see gear 2 and gear 3, ये दोनों एक ही शाफ्ट में माउंट है. ये है gear 2, this is gear 2, and this is gear 3. दोनों एक ही शाफ्ट में माउंट है. That means n2 equal to n3, and again gear 4 and gear 5, ये दोनों एक ही शाफ्ट में माउंट है. ये कॉमन शाफ्ट है between gear 4 and gear 5. So n4 is also equal to n5. So n2 equal to n3, n2 equal to n3, and n4 equal to n5. n2 equal to n3 and n4 equal to n5. That means ये जो इक्वेशन है यहाँ पे n2 कट गया, n3, ये दोनों एलिमिनेट हो गया, n2 n3 get eliminated. Then n4 and n5, ये दोनों भी eliminated हो गया. That means finally we have got n6 by n1 equal to t1 into t3 into t5 by t2 into t4 into t6. So see, n6 by n1 is nothing but the velocity ratio of this compound gear train, which is nothing but the ratio between product of the teeth of the driver, product of the teeth of the drivers, product of the teeth of drivers by product of teeth of followers. देखो, gear 1, gear 3 and gear 5 they are driver, and gear 2, gear 4 and gear 6 they are followers. Next question, question number E. No, question number D. Derive the relation between mechanical advantage, velocity ratio and efficiency of a machine. So we will derive question number E. You have to derive the relation between mechanical advantage, velocity ratio and efficiency of a lifting machine. Suppose a pulley is there, not pulley, a worm wheel. This is a worm wheel is there. Okay. So on the one side there is a load of P Newton, and on the other side there is a handle by means of which we can lift the load upward by moving the handle upward or downward direction. Okay, when the handle moves downward, let's the distance traveled by the handle be, let's the distance traveled by the handle be x, and at the same time load is traveling a distance of suppose y, and let x is not equal to y. Okay, x is not equal to y, and ये जो रोप जो है, ये रोप यहाँ पे it will get stored over here. Then when we calculate mechanical advantage, it is the ratio of load to effort. It is a ratio of load to effort. Okay, so P be the load, let we can represent effort by PE. That means P by PE, that is mechanical advantage. Then for this case, velocity ratio for a lifting machine can be defined by the distance traveled by effort by distance traveled by load. This is the velocity ratio for a lifting machine. Then for any machine we know the efficiency is आउटपुट बाय इनपुट. सो आउटपुट में वर्क डन हो रहा है, वर्क डन बाय द लोड. आउटपुट इज वर्क डन by load, and input is nothing but the work done by effort. So work done by load is P into, this is the distance traveled by load, so P into Y, and work done by effort is PE into X, that is P by PE into Y by X, or we can write P by PE into 1 by X by Y, that is the efficiency. And again, efficiency equal to P by P. See the formula. P by P is the mechanical advantage, and velocity ratio VR equal to distance travel by effort. Distance travel by effort कितना है? X. Distance travel by load is Y. X by Y is our velocity ratio. So P by PE by X by Y, that means mechanical advantage by velocity ratio. So the relation between mechanical advantage, velocity ratio, and efficiency of lifting machine is this. Efficiency is mechanical advantage by velocity ratio. Okay, so this much only needed to solve the question. Next question, question number F. Find the position of centroid of I section having following dimension. Bottom flange is 300 mm into 50 mm. Top flange equal to 150 mm into 50 mm, and wave equal to 300 mm into 50 mm. Let's draw the diagram. Suppose this one is the top flange, then suppose this one be the wave, and this one be the bottom flange. So this is the I section as for the question. This is the top flange whose dimension is 150 into 50 mm. This is the wave whose dimension is 300 into 50 mm. This is the bottom flange whose dimension is 300 into 50, and we have to calculate the centroid. So as I have told you before during the discussion of centroid, first we have to analyze whether this is a simple figure or compound figure, and I can clearly say that this is a compound figure, and in this compound figure we are observing a symmetry about vertical axis. So we are observing the symmetry about vertical axis. So see, if this is our vertical axis, okay, let me draw the axis first. Suppose this is the vertical axis, and you can see this is symmetry, both sides are symmetrical. This, suppose This is x-axis. Okay, this total line is lying on x-axis, and this is our y-axis, and this is with the origin. And whenever you are coming across such type of question, always try to find out symmetry. Is there any symmetry in this figure? Yes, there is symmetry. The figure is symmetry about y-axis. Okay, not the y-axis but vertical axis. Okay, this is the vertical axis, and this figure is symmetrical about this vertical axis. देखो वर्टिकल एक्सिस के लेफ्ट हैंड साइड में जो भी है राइट हैंड साइड में सेम फिगर है, ठीक है. सिमेट्री. So symmetry मतलब here we can calculate directly the x bar. Directly calculate x bar. X bar is nothing but 300 by 2, exactly the midpoint, that is 150. That means x bar is lying at a distance of 150 millimeter from the origin along x-axis. Along x-axis. Okay. So ये जो सिमेट्रिकल एक्सिस जो है, सिमेट्रिकल ये जो वर्टिकल एक्सिस है, वर्टिकल एक्सिस, दिस वर्टिकल एक्सिस एक्स एक्सिस में 150 मिलीमीटर में इंटरसेक्ट कर रहा है. दिस वर्टिकल एक्सिस is intersecting x-axis at a distance of 150 millimeter from the origin. So only we need to calculate y bar because this figure is not symmetry about horizontal axis. So y bar calculate करने के लिए हमको क्या calculate करना पड़ेगा? इंडिविजुअल सेक्शन का एरिया, इंडिविजुअल सेक्शन का सेंट्रोइड. So y bar formula is a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3, a1 plus a2 plus a3. So see, ये टॉप फ्लैंज है, ये टॉप फ्लैंज लेट दिस इज आवर एरिया 1, दिस वेव लेट बी आवर एरिया 2, and this bottom flange be our area 3. Okay, so टॉप फ्लैंज का एरिया कितना होगा? 150 into 50. वेव का एरिया कितना होगा? 300 into 50. बॉटम फ्लैंज का एरिया कितना होगा? 300 into 50. सो कैलकुलेट करते हैं फॉर एरिया 1. एरिया 1 इक्वल टू 150 into 50, एंड एरिया 1 का जो y बार जो है, y1 बार जो है, इसका y1 बार कहाँ पे रहेगा? 50 by 2 plus this distance. So y1 will be lies at distance of 50 by 2 plus 50, that is the width of the bottom flange, 50 plus 300, and 300 जो है ये 300, this 300. Okay, so 50 by 2, so this is our 50 by 2 plus 50 plus 300. This is nothing but a1 and y1. a1 y1 plus a2 y2, 300 into 50 into 300 by 2 plus 50. So this is our section 2. So section 2 का y2 बार कहाँ पे रहेगा? This distance is 300 by 2 plus this distance, 50 plus 300 by 2, जितना डिस्टेंस रहेगा उतना डिस्टेंस पे सेक्शन 2 का सेंट्रोइड विल लाई. एंड सेक्शन 3 एरिया 300 into 50 into only 50 by 2 by total by this total by 2 into 300 into 50 plus 150 into 50. then we can calculate directly by the help of calculator that y bar equal to 165. So now we have got the centroid. Position of centroid x bar y bar equal to 150 165. Answer. Then next question, a ball of mass 2 kg moving with a velocity of 2 meter per second hits directly on a ball of mass 4 kg at rest. The first ball after impending comes to rest. Find the velocity of second ball after the impact and the coefficient of restitution. ओके, सो गिवन क्या क्या है, बॉल का मास गिवन है एंड फास्ट बॉल का वेलोसिटी गिवन है. So from the question directly we can get this is bit number G. So there are two ball, the ball 1 which is moving, another ball 2 which is at rest. Okay, ball 1 ball 2. So ball 1 जो है वो मूव कर रहा है at a velocity of, let u1 be the velocity of initial velocity of ball 1 and the velocity given 2 meter per second, 2 meter per second, and mass of ball 1 given, let m1 be the mass of ball 1. Okay, mass of ball 1 given 2 kg, 2 kg, and initially ball 2 is at rest. That means the velocity of ball 2 u2 initial velocity is 0 and mass of ball 2 is equal to 4 kg, 4 kg. And another, what are the data given, let's see. The first ball after impending comes to rest. Find the velocity of second ball after the impact and coefficient of restitution. So these are the condition before colliding. They are colliding, ball 1 and ball 2, and after colliding ball 1 is coming to rest. That means final velocity of ball 1 is 0 and ball 2 is moving. So we don't know the final velocity of ball 2. We have to calculate the final velocity of ball 2 as well as we have to calculate the coefficient of restitution, that is E. So see, all this total event is taking place in a single line or they are following a linear motion. So we can put the conservation of momentum concept over here. So it is saying that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Momentum before colliding is equal to momentum after colliding. We know the initial velocity of ball 1, that is 2 kg. We also know the initial velocity of ball 1 is 2 meter per second. So 2 kg is mass of ball 1 and 2 meter per second is initial velocity of ball 1. We know the mass of ball 2 which is equal to 4 kg. into velocity is not given because it is at rest, so 0, u2 is 0. Then m1 is also 2 kg, but final velocity of ball 1 is 0 because after impending the ball 1 is coming to rest. Ball 2 4 kg and v2, we have to calculate the v2. So we will get 4 plus 0 equal to 4 into v2 plus 0. Okay, that means we will get v2 equal to 1 meter per second, 1 meter per second. Then calculation of coefficient of restitution. Coefficient of restitution is the ratio between velocity of separation to velocity of approach. Velocity of separation to velocity of approach. That means E equal to v1 v2 minus v1 by u1 minus u2, and v2 we have got 1 meter per second, v1 we have got 0, u1 given 2 meter per second, u2 given 0. So E equal to 1 by 2 or 0.5. This is our answer, and this is unitless. Remember, coefficient of restitution is unitless. Okay, so we have got the answer. We have got the velocity of ball 2, that is 1 meter per second, and coefficient of restitution, that is 0.5. Next we will discuss 10 marks type question. Question number 3 is saying find the moment of inertia of a T section having flange and wave both 120 millimeter into 30 millimeter about x axis passing through the center of gravity of the section. So this is the T section. The top flange is 120 into 30 millimeter, and the wave is also 120 millimeter into 30 millimeter. So in this particular section, according to question, we have to calculate the moment of inertia about at axis x, let this be the axis x, and this axis is passing through the centroid, So about this axis we have to calculate the moment of inertia. So first we have to locate the, first case we have to locate the centroid. So after locating the centroid, we have to calculate the moment of inertia of each individual area consisting the T section about the axis by the help of parallel axis theorem, and after then we have to add the result. So let this top flange be area 1 and wave be the area 2. So whenever we are intending to find out the centroid, first we have to see is there any symmetry. So in this figure there is a symmetry, and the figure is symmetry about axis, a vertical axis passing through the centroid. So let this vertical axis is passing through centroid, and about this axis this figure is symmetry. How symmetry? LHS साइड में हमको जो भी दिख रहा है RHS साइड में भी हमको वही दिख रहा है। ये एक्सिस जो है, ये एक्सिस का लेफ्ट हैंड साइड में हमको जो दिख रहा है राइट हैंड साइड में भी वही दिख रहा है। सो दिस इज सिमेट्री अबाउट दिस वर्टिकल एक्सिस। ओके, so symmetry about vertical axis means इसका x bar जो है it will lie at a distance of 120 by 2, that is 60 millimeter from this edge। ये जो edge है, let this edge be, हम नेमिंग कर देते हैं AB। ये AB edge से ये 60 मिलीमीटर डिस्टेंस पे रहेगा। ओके, सपोज let this is be our x axis and this is be our y axis and this is our origin. In this case we can calculate the y bar by the formula a1 y1 plus a2 y2 by a1 plus a2, and we know a1 and a2 are of same magnitude, so directly I am writing 120 into 30। so here a1 and a2 में से दोनों का एरिया जो है कॉमन है, सो वो उसको मैं कॉमन ले, आई हैव टेकन दैट कॉमन। सो y1 प्लस y2 by 2 into 120 into 30। ओके, सो 120 into 30 जो है it will get cancel out from top and bottom for numerator and denominator। so y1 का वैल्यू कितना है, y1 वैल्यू इज द CG of सेक्शन 1 एंड सेक्शन 1 जो है ये टॉप फ्लैंज है। सो y1 का वैल्यू कैसे कैलकुलेट करेंगे, यू कैन कैलकुलेट बाय एडिंग दिस डिस्टेंस एंड दिस इज y bar, y1 bar, it is 30 by 2 plus this distance 120। so y1 equal to 120 plus 30 by 2, and y1 is not the centroid of figure 1, y1 is the distance of the centroid of figure 1 from the origin। okay, correction, y1 is not the centroid of the figure 1, but it is the distance of the centroid of figure 1 from the origin। that's why यहाँ पे हम लोग ऐड कर दिए this CG, that is 30 by 2 plus 120। तो 30 by 2 plus 120 y1 प्लस y2 का वैल्यू कितना होगा, डायरेक्टली 120 है 2। सो 120 प्लस 30 by 2 प्लस 120 by 2 by 2 इक्वल टू 135 plus 60 by 2, which is equal to 97.5। so we have got y bar, so this axis, ये जो x axis जो है, now we have located this x axis which is passing through the CG of the figure, and that is nothing but 97.5 millimeter from the origin। then we will calculate the moment of inertia of figure 1 about x axis। moment of inertia of figure 1 about x axis, let I1 be the moment of inertia of figure 1। I1 equal to Ig1 plus A1 H1 square. So Ig1 is moment of inertia of figure 1 about its centroid. A1 is the area of figure 1. H1 is the perpendicular distance between centroid of figure 1 and the centroid of the total figure or x axis. So first we have to calculate here we have to calculate first Ig1 Ig1, it's a rectangle, so it Ig1, this is rectangle, about we are calculating about this axis. Let me show you the axis in different color. Okay, suppose this is with the centroid of figure 1. Okay, so first we are calculating Ig1. So Ig1 क्या हो जाएगा? Ig1 will be, we know the moment of inertia of rectangle is BD cube by 12, and here we can write the Ig1 is B1 D1 cube by 12, and this is B1, this is D1. So Ig1 is B1 D1 cube by 12, which is equal to B1 value is given as 120, D1 is 30 cube by 12, so that is equal to 120 into 30 cube by 12, 27 into 10 to the power 4 millimeter to the power 4, 27 into 10 to the power 4 millimeter to the power 4, and this is our Ig1. Then we will calculate H1, that is the distance between your centroid of figure 1 to centroid of total figure or x-axis. The centroid of figure 1 is lying at a distance of 120 plus 30 by 2 from origin. If we subtract the position of y bar from this distance, then we will get the H1, and we have already calculated y1 bar, which is equal to 97.5. so 97.5 can be subtracted from 135, so H1 will be 37.5 millimeter. So I1 equal to Ig1 27 into 10 to the power 4 plus A1 120 into 30 into H1 37.5 square. So by the help of calculator we can calculate it. 27 into 10 to the power 4. Okay, I am calculating by using calculator. 120 into 30 into 37.5 square, which is equal to 5332500. 5332500 mm to the power 4. This is figure of moment of inertia of figure 1 about x axis. Then we will calculate the moment of inertia of figure or area 2 about x axis in the same manner. So let I2 be the moment of inertia of figure 2 area 2 about x axis, which is equal to I g2 plus a2 h2 square. So you can calculate Ig2 by following the formula B2 D2 cube by 12, and B2 is 30, D2 is 120 cube by 12, which is equal to 432 into 10 to the power 4 millimeter to the power 4. Then we will locate H2. H2 can be calculated by simply subtracting the y bar from y1, and y1 minus y bar, y1 equal to 60 minus 97.5. So 60 minus 97.5 is equal to minus 37.5, minus 37.5. So this is the distance. So distance can never be negative. So h2 can be taken as mod 37.5. So h2 is 37.5. So let's calculate. I2 equal to Ig2 432 into 10 to the power 4 plus A2 is 120 into 30 into 37.5 square, which is equal to, we can calculate by the help of calculator, 9382500 mm4, which is I2. Now by simply adding I1 and I2, we can calculate Ixx, which is nothing but moment of inertia of the figure about x axis passing through the centroid of the figure. So Ix equal to I1 plus I2. So I1 is 533 2500 533 2500, and I2 is equal to 938 2500 mm to the power 4. So finally we will get 533 2500 plus 938 2500 equal to 1471 5000 1471 5000 mm to the power 4. So इसको हम we can also write in another way, 14.715 into 10 to the power 6 mm to the power 4, which is Ixx and our answer. Okay, this is how we have to answer this question. Next question is about friction concept. A uniform ladder AB 3 meter long, weight 200 Newton. It is placed against a wall making an angle 60 degree with the floor. The coefficient of friction between the wall and the ladder is 0.25, and that between the wall, sorry, the floor and ladder is 0.35. The ladder, in addition to its own weight, support a man of 1000 Newton at its top at B. Calculate the horizontal force P to be applied to the ladder at the floor level to prevent slipping. So let's understand this question bit by bit. First is given a uniform ladder AB 3 meter long weighing 200 Newton. That means एक ladder है which is uniform in nature, that means weight is divided uniformly, and ladder का length जो है वो 3 मीटर है, and its weight, उसका weight जो है वो 200 न्यूटन है. It is placed against a wall making an angle 60 degree with the floor. Okay, that means question number 4. This is be our floor, and this is be our wall, and in between this floor and wall a ladder is there. एक ladder है, ये है हमारा ladder. Okay, and ladder is A, B. This is our ladder, and ladder का जो length है that is AB equal to 3 meter, and ladder का जो weight है W, let W be the weight of ladder which is given as 200 Newton, and always remember this weight will act at center of ladder. ladder का जो center है वहाँ पे ही weight act करेगा. So let this is the point where weight is acting, and weight का value कितना है 200 Newton. Apart from this, what are the data given in the question? The ladder is placed against the wall making an angle 60 degree with the floor. So this angle is 60 degree. This angle is 60 degree. ये जो angle है इसका value given है 60 degree. Let's name this O. This is our wall, and this is our floor. Okay. Again, what are the data? Let me see the question again. The coefficient of friction between the wall and the ladder is 0.25, and wall and the floor and the ladder is 0.35. Let mu W be the coefficient of friction between the wall and ladder, and this is given is 0.25. wall and ladder के बीच फ्रिक्शन given है 0.25, and let mu F be the coefficient of friction between floor and ladder, and इसका वैल्यू कितना given है 0.35. Okay, these two value are given. Another data is given. In addition to its own weight, the ladder has to support a man standing at the top and weighing 1000 न्यूटन। सो यहाँ पे बी पोजीशन पे, ये बी पोजीशन पे एक आदमी खड़ा हुआ है। ओके, एक आदमी खड़ा हुआ है जिसका वेट का वैल्यू गिवन है, वेट विल एक्ट डाउनवर्ड, जिसका वेट का वैल्यू गिवन है, वेट ऑफ पर्सन इज गिवन एज 1000 न्यूटन, 1000 न्यूटन। सो इतना डाटा गिवन है। सो कैलकुलेट करने के लिए बोला है कितना फोर्स पी, व्हाट इज द वैल्यू ऑफ फोर्स पी अप्लाइड at the bottom so as to prevent slip of the ladder। so bottom, अगर लैडर का बॉटम में हम कितना फोर्स अप्लाई करेंगे लैडर को स्लिप करने से रोकने के लिए, ठीक है। सो ये P का वैल्यू हमको निकालना पड़ेगा। सो लेट्स ड्रॉ द फ्री बॉडी डायग्राम। फ्री बॉडी डायग्राम ड्रॉ करते हैं। दिस इज आवर लैडर। लैडर का वेट जो है इट विल एक्ट एट द सेंटर। सो यहाँ पे वेट एक्ट कर रहा है, इसका वैल्यू है 200 न्यूटन, एंड बिटवीन द वॉल एंड द लैडर, व्हेन द लैडर जो है यहाँ पे एक फ्रिक्शनल फोर्स एक्ट करेगा, एंड दैट फ्रिक्शनल फोर्स विल एक्ट इन द ऑपोजिट डायरेक्शन ऑफ स्लिपिंग। सो अगर लैडर स्लिप करेगा वो टॉप साइड से, तो वो डाउन साइड से स्लिप करेगा, टुवर्ड्स डाउनवर्ड स्लिप करेगा। दैट मीन्स फ्रिक्शनल फोर्स जो वॉल का रहेगा इट विल एक्ट एट टॉप डायरेक्शन। ओके, एंड अगेन वॉल जो है इट विल प्रोवाइड ए रिएक्शन एंड दैट इज RW। एंड अगेन यहाँ पे एक आदमी खड़ा हुआ है जिसका वेट गिवन है 1000 न्यूटन। देन एट द बॉटम, बॉटम पे क्या हो रहा है कि बॉटम पे वी आर प्रोवाइडिंग ए फोर्स P, एक P फोर्स प्रोवाइड कर रहे हैं, P फोर्स प्रोवाइड कर रहे हैं स्लिपरी को, स्लिपिंग को प्रिवेंट करने के लिए। और जब स्लिप होगा, जब एक्चुअली स्लिप होगा, लैडर किस डायरेक्शन में स्लिप होगा, लैडर विल स्लिप इन दिस डायरेक्शन। जब लैडर नीचे गिरेगा इट विल स्लिप इन दिस डायरेक्शन और नॉट, टुवर्ड लेफ्ट हैंड साइड में वो स्लिप करेगा। दैट मीन्स इसका दो फ्रिक्शनल फोर्स जो है ऑपोजिट टू द डायरेक्शन ऑफ स्लिपिंग रहेगा। ऑपोजिट टू द डायरेक्शन ऑफ स्लिपिंग मीन्स इन द सेम डायरेक्शन, इन द सेम डायरेक्शन फ्रिक्शनल फोर्स एक्ट करेगा, एंड लेट द फ्रिक्शनल फोर्स बी F। एंड अगेन the floor will provide a reaction force and that is RF। ये हो गया हमारा फ्री बॉडी डायग्राम। ओके, FW is the frictional force provided by the wall, FF be the frictional force provided by the floor, P is the applied force to prevent the slipping, 1000 Newton is the weight of the man, 200 Newton is the weight of the ladder, RF and RW are the reaction force provided by the support at the floor level and wall level to the ladder. So now we first resolve all the force horizontally. Let's resolve forces horizontally। जब हम हॉरिजेंटल रिजॉल्व करेंगे, हॉरिजेंटल फोर्स क्या क्या है, RF एक हॉरिजेंटल फोर्स है, सॉरी RW एक हॉरिजेंटल फोर्स है, F एक हॉरिजेंटल फोर्स है, एंड P एक हॉरिजेंटल फोर्स है। दैट मीन्स P एंड FF आर इन सेम डायरेक्शन। दैट मीन्स ये दोनों को हम ऐड करेंगे इज इक्वल टू RW, बिकॉज RW जो है वो ऑपोजिट डायरेक्शन में है, ठीक है। एंड लेट नेम दिस इक्वेशन एट इक्वेशन H equation 1। Again we will resolve forces vertically। so vertically कौन कौन सा फोर्स एक्ट हो रहा है, वर्टिकली फोर्स क्या क्या है, वर्टिकल फोर्स एफ डब्ल्यू है 100 न्यूटन 1000 न्यूटन है, 200 न्यूटन है एंड आर एफ है. सो आर एफ प्लस एफ डब्ल्यू इक्वल टू 1000 plus 200 because आर एफ and एफ डब्ल्यू are in same direction. Suppose that means they will lie in same side, and 1000 Newton and 200 Newton are the weight of the body and the ladder. That means that will act downward. That means they will lie in opposite to the direction of RF plus FW. So RF plus FW equal to 1200 Newton, and this is B equation 2. Okay, so देखो यहाँ पे क्या क्या हो गया, आर एफ एफ डब्ल्यू पी एफ डब्ल्यू एफ एफ एंड आर डब्ल्यू. देखो यहाँ पे कितना अननोन है हमारे पास, 1 2 3 4 5 तो अननोन है. ओके, दैट मीन्स दो तो इक्वेशन लेके हम लोग इसको सॉल्व नहीं कर सकते हैं. सो वी हैव टू टेक फाइंड another equation. So another equation means we will take the help of moment. Moment का help लेंगे. This is A, this is B. Let me draw the floor. This is the floor line, and let this is be our wall line. Okay, and यहाँ पे हम moment का help लेंगे. Suppose let's take moment about A. Take moment about A. So moment about A जब लेंगे, so this is 200 Newton, 100 Newton, RW प्लस यहाँ पे एक फोर्स रहेगा, इट इज एफ डब्ल्यू. So in this equation we have to divide both side by cos 60. When we divide, in the left hand side we will get 300 into 3000 equal to, in the right hand side we will get 3FW plus 3RW 1060. Then further we will get 3300 equal to 3FW plus RW 1060, or 1100 equal to FW प्लस आर डब्ल्यू 1060 का वैल्यू दो इज √3 एफ डब्ल्यू प्लस √3 आर डब्ल्यू, एंड लेट्स गिव दिस इक्वेशन एज इक्वेशन 3. ओके, एंड सी ये जो एफ डब्ल्यू जो है ये फ्रिक्शनल फोर्स विथ रेस्पेक्ट टू वॉल है, and frictional force with respect to wall is nothing but mu w into rw. okay, and mu w का वैल्यू हमको पता है, इट इज 0.25 into rw. सो fw जो है इज इक्वल टू 0.25 rw. सो अभी इस वैल्यू को लेके हम इक्वेशन 3 में पुट करेंगे. सो नाउ equation 3 will be 1100 equal to 0.25 RW plus √3 RW. So we will get Rw equal to 1100 by 0.25 plus root 3, which is nothing but 1.982. 1.982. The total will be 555 न्यूटन, और ये हमारा मिल गया Rw को वैल्यू, Rw का वैल्यू हमको मिल गया. So now we have got Rw, which is equal to 555 Newton. Then we will calculate Fw. Fw will be 0.25 Rw, or 0.25 into 555 Newton, which is equal to 138.7 न्यूटन. सो ये हमारा मिल गया Fw का वैल्यू. आफ्टर गेटिंग Fw वैल्यू, नाउ ये जो Fw का वैल्यू है उसको हम इक्वेशन 2 पे पुट करेंगे. ओके, एंड इक्वेशन 2 क्या था? इक्वेशन 2 इज Rf प्लस Fw इक्वल टू 1200, एंड हम लोगों को मिल गया कि Fw का वैल्यू इज 138.7 न्यूटन. सो अभी ये वैल्यू को लेके इस इक्वेशन में पुट करेंगे. सो वी विल गेट Rf प्लस 138.7 इक्वल टू 1200, और Rf इक्वल टू 1200 माइनस 138.7, और Rf reaction force provided by the floor to the ladder is equal to 1061.3 न्यूटन. तो अभी Rf भी हमको मिल गया. सो ये जो Rf का वैल्यू मिला है इसको लेके हम इक्वेशन 1 में पुट करेंगे. विल पुट दिस वैल्यू इन इक्वेशन 1. एंड इक्वेशन 1 क्या था? इक्वेशन 1 इज P प्लस Rf इक्वल टू, इक्वेशन 1 था P प्लस Rf, ओके, P प्लस Ff इक्वल टू Rw. P प्लस Ff, okay, let me rewrite the equation 1. This is not the Rf. P plus Ff equal to Rw. ओके, एंड ये कैसे पुट करेंगे इक्वेशन 1 में? बिकॉज P प्लस म्यू Rf इक्वल टू Rw, और P प्लस म्यू का वैल्यू कितना है? इट इज म्यू फ्लोर का वैल्यू है 0.35 into Rf is 1061.3 Newton equal to Rw is 555 Newton. So finally इसको कैलकुलेट करने से हमको मिल जाएगा P, और the load applied at the bottom of the ladder so as to prevent the slip is equal to 183.5 Newton, and this is our answer. Okay, this is how we have to solve ladder problem, and after then you will get 10 out of 10 mark. Next question, question number 5. A simple screw jack has a thread of pitch 12 mm. Find the load that can be lifted by an effort of 20 Newton applied at the end of the handle 500 mm long. Take efficiency of the machine as 50%. देखो एक स्क्रू जैक है जिसका थ्रेड का पिच है 12 मिलीमीटर, and our aim is to calculate the load जो कि जैक लिफ्ट करेगा by the help of an effort, जो कि हम प्रोवाइड करेंगे. effort is the force provided by us of 20 Newton applied at the end of the handle, which is 500 millimeter long, and efficiency is given 50%. तो देखो, दिस इज ए स्क्रू जैक. स्क्रू जैक के टॉप में लोड है, ये लोड है, एंड लोड का वैल्यू गिवन है कितना? लोड का वैल्यू गिवन एच, लोड का वैल्यू गिवन नहीं है. सो लोड का वैल्यू वी हैव टू कैलकुलेट लोड. So this is our effort. We are providing effort at the handle, and effort is given as 20 Newton. It is our effort. Length of the handle, this is L. L is the length of handle, and length of the handle given as कितना वैल्यू गिवन है हैंडल का लेंथ? इट इज गिवन एज 500 मिलीमीटर. 500 मिलीमीटर. एंड ये जो मशीन का इसका एफिशिएंसी इज गिवन एज 50%. ओके, और इतना ही डाटा गिवन है. by the help of this much of data we have to calculate the load. Another data is given, each pitch that is 12 millimeter. pitch is 12 millimeter. and pitch क्या होता है? देखो, by the help of this handle हम इसको रोटेट करेंगे. ये रोटेट होगा, ऐसा रोटेट करेगा, ठीक है. जब ये रोटेट होगा, देखो यहाँ पे थ्रेड है. इन वन रोटेशन ये इस थ्रेड जो है इट विल ट्रैवल, ये जो एक्सिस है, ये एक्सिस ट्रैवल करता है 12 millimeter distance. Okay, that means we can say distance traveled by load, let that be y, is equal to 12 millimeter. 12 millimeter. एंड हैंडल का लेंथ गिवन है, दैट इज इक्वल टू 500 मिलीमीटर. सो ये 500 मिलीमीटर को लेके वी कैन कैलकुलेट डिस्टेंस ट्रैवल बाय एफर्ट. सो एफर्ट क्या है? ये एल है. सो ये जब हैंडल एक रोटेशन रोटेट कर रहा है तभी जाके लोड एक्सिस 12 मिलीमीटर डिस्टेंस ट्रैवल कर रहा है. सो द सर्कमफ्रेंस ऑफ दिस सर्किल will be the distance traveled by the effort, and that is equal to 2 pi L. Okay, 2 into 3.14 into 500, which is equal to 3140 millimeter. So from this we can calculate the velocity ratio. Velocity ratio is distance traveled by effort by distance traveled by load. So 3140 by 12, which is equal to 261.66. No unit. Then we know the efficiency formula of lifting machine is mechanical advantage by velocity ratio. and mechanical advantage is the ratio between load to effort into 1 by velocity ratio, and efficiency is given as 50%. 50% is equal to, we don't know the value of W, but we know the value of effort. Effort का value कितना given है? 20 Newton. So effort is 20 Newton into 1 by velocity ratio 261.66 is our velocity ratio. So 50% means 0.5 equal to W by 5233.33 or W equal to 2616.66 Newton. So this is our answer. This is the value of load to be lifted by this lifting machine or this screw jack. Okay, देखो यहाँ पे क्वेश्चन पे 50% गिवन है. So if 50% जो गिवन है efficiency, अगर screw jack का efficiency is less than 50%, that means it is a self-blocking machine. Okay, remember this point. 2-mark question. Next, question number 6. And let's see the question number 6. Prove the moment of inertia of a rectangular section having width B and depth D about x axis is B D cube by 12. Let's me draw the rectangle. Suppose this one is the rectangle. Okay. Suppose this is be the x axis passing through the centroid. Okay. So passing through the centroid, which is x axis, and as per the question, the width is B and depth is D. Depth is D. So we have to prove Ix equal to BD cube by 12. BD cube by 12. So see, this is a rectangle section, and rectangle section का जो centroid है, centroid is lie as geometric mid. Geometric mid, that is B by 2 and D by 2. यहाँ पे centroid रहेगा. So the bottom side, this bottom side is nothing but D by 2 distance, and this top side is nothing but D by 2 distance, and x axis is passing through the centroid. Okay, let's take a small section over here. So let's take a small section. Whose centroid is lying at a distance of y by 2, sorry, not y by 2, y from the x axis, and let the side or the depth of this section is dy. Okay, a small strip का area the area of this small strip will be dA, which is equal to B dy, dA equal to B dy, and we know the moment of inertia of any area about any axis is equal to the product of area and the square of this perpendicular distance between the axis and the centroidal axis of that area. So this is will be dA y square, dA y square, or we will get, for small area we are calculating, so dIXS will, this is dIXS, so dIXS will be B dy y square, or B y square dy. Total moment of inertia can be calculated by integrating this equation from b by 2, okay, minus d by 2 to d by 2. That means Ixx equal to integration from minus d by 2 to d by 2 b y square dy. So y माइनस डी बाई टू, डी बाई टू, देखो ये नीचे का सेक्शन जो है, नीचे का सेक्शन इज अप टू डी बाई टू डिस्टेंस एंड टॉप सेक्शन इज अप टू ऑल्सो डी बाई टू डिस्टेंस. So अगर if we move downward we will take negative, the sign will be negative. If we move upward the sign will be positive. So the limits of the integration is from minus d by 2 to d by 2. and see यहाँ पे ये जो है कोफिशिएंट जो है, इंटीग्रांड जो है, ये इंटीग्रांड इज ए even function. So even function means this equation further can be reduced to 2 into 0 to b by 2 by square dy. So 2 b y cube by 3 0 to b by 2. So 2b, okay, 0 to not b by 2, d by 2. Okay, some typing mistake is there, so let me change the typing mistake. Okay, let me correct. So 0 to d by 2, so d cube by 3 into 2 cube minus 0, or 2b d cube by 3 into 8, or Ixx equal to b d cube by 12. Okay, proved. So we have proved that the moment of inertia of a rectangle having width b, depth d, about an axis xx passing through the centroid is equal to BD cube by 12 when the axis is horizontal in nature. So next we will solve the last question, that is question number 7. Question number 7. The forces 20 Newton, 30 Newton, 40 Newton, 50 Newton and 60 Newton are acting at one of the angular points of a regular hexagon towards the other 5 angular points taken in order. Find the magnitude and direction of resultant force. So let's draw a hexagon. एक हेक्सागन हम ड्रॉ करते हैं पहले. So this is a hexagon and क्वेश्चन में गिवन है कि the forces 20 Newton, 30 Newton, 40 Newton, 50 Newton and 60 Newton are acting at one point. Suppose this is O point and इस O point में ये सारे फोर्स एक्ट कर रहे हैं, ठीक है, and they are acting at one point towards the other five point, ठीक है. That means so first जो फोर्स रहेगा नेमिंग कर देते हैं. दिस इज ए, दिस इज बी, दिस इज सी, दिस इज डी, दिस इज ई, दिस इज ओ. सो फर्स्ट फोर्स जो है एक्ट करेगा फ्रॉम ओ टुवर्ड्स ए. दिस इज फर्स्ट फोर्स. लेट्स दिस फोर्स इज गिवन एज आई थिंक 20 न्यूटन, 20 to 60 न्यूटन, राइट. सो 20 न्यूटन which is given as 20 न्यूटन. सेकेंड फोर्स जो है इट इज एक्टिंग एट पॉइंट बी में एक्ट कर रहा है एंड दैट इज 30 न्यूटन. थर्ड फोर्स जो है थर्ड फोर्स इज एक्टिंग एट पॉइंट सी फ्रॉम पॉइंट ओ एट पॉइंट ओ टुवर्ड्स पॉइंट सी, दैट इज 40 न्यूटन. फोर्थ फोर्स जो है वो एक्ट कर रहा है एट पॉइंट ओ and the sense is towards point D, towards point G, 50 Newton. and next force जो है 60 Newton force, it is acting towards point E and 60 Newton. and remember regular hexagon का each angle is 120 degree. so यहाँ पे 1 2 3 4 we are dividing 120 degree by 4, that means each angle is 30 degree. That means each angle is 30 degree. ये 30 डिग्री हुआ. ये एंगल कितना हो जाएगा? दिस एंगल विल बी 60 डिग्री. दिस एंगल इज 90 डिग्री and this angle will be 120 degree. so we have to calculate the resultant. resultant कैसे calculate करेंगे? resultant is summation of fx square of summation of fy root over. This is the formula for resultant. so first we have to resolve all force horizontally. Resolving forces horizontally, that is summation of force along x direction, we will get 20 plus 30 cos 30 degree plus 40 cos 60 degree plus 50 cos 90 degree plus 60 cos 120 degree. so by the help of calculator we can add all this value and we will get summation of all the force along x direction is equal to 36 Newton. Okay, so sigma fx is 36 Newton. Then we will calculate sigma fy by resolving forces along y direction or vertically So we will get sigma fy equal to 20 sin 0 degree plus 30 sin 30 degree plus 40 sin 90 degree. Okay, 40 sin 60 degree plus 50 sin 90 degree plus 60 sin plus 60 sin 120 degree. Okay, so by the help of calculator we can calculate sigma fy equal to 151.6 Newton. This is our sigma fy. So now we can calculate the resultant. So resultant R is equal to root over of square of summation of all force along x direction plus square of summation of all force along y axis. So sigma fx is equal to 36 Newton square plus sigma fy 151.6 square root over. So R equal to 155.8 Newton, and this is our answer. Next bit is to calculate the direction of resultant. So resultant direction is theta equal to tan inverse sigma fy by sigma fx, okay, equal to tan inverse 151.6 by 36. So this value can calculate by the help of calculator, which is equal to 76.6 degree theta. This is our answer. Okay, so here we have calculated resultant and theta, and here the total solution of 2022 winter semester is completed. I hope you have learned how to solve the question paper. Apart from watching this video, solve all this numerical at least once. Do the practice. I hope you will get success in your semester exam and you will secure good marks. If you have any doubt, then put that doubt in the comment box. Please ignore if any writing mistake are there. To see more of such kind of lecture, subscribe to my channel, like this video, and stay updated. बेस्ट ऑफ लक फॉर योर एग्जाम।